shared with all the participants after the session is completed. And if the PPTs are provided, we'll also share the PPT or the PDF with all the participants. Okay, with that, with no more ado, I would like request Syed Yasin Saab to please take it on.
Okay. Assalamu alaikum, everybody. Okay. Before we proceed, you're able to hear me?
Yeah, we are able to hear you. If you can put it on the presentation mode, it will be much helpful.
I'll be switching the screens, which is why I've kept it this way. I have to keep hitting the escape now and then. So I'll be trying to make a little interactive session, which is why I'll go with this pace.
Sure.
Just in case I'm speeding up, you can always slow down me a bit. I'll try to cover as much as I can within whatever time we have. I'm trying to see if I can do this a little over 1 hour. And if we are yet to complete, then probably we can have a session, sometime later, inshallah, whatever is remaining. So, alhamdulillah, before we start, Munir Bhai gave you a brief background about my humble work. You can actually go through this link. The Fiki has created an elevator pitch on this link. Let me put this on a chat box so that you can basically see whenever you have time. Like, so I've shared that, and then let's go see to basically understand AI. The technology or the math behind the AI, it's more towards the math. Typically, when we talk about AI, most of the time, what I've heard people saying, talking, discussing is about TensorFlow, Python, about neural networks, and all that. I have to tell you that all that is fine, but the basic idea, the basic essence of AI is all about math. It's nothing but math. So you have to have this in mind that when you talk about AI, you're actually talking about mathematics, nothing else. So if you have fundamental concepts of math, statistics, strong, then the subject would be much more interesting to understand what's happening beneath the hood of what TensorFlow is doing, what some of the Python libraries are doing. It'd be fun to actually work with. There is a difference between an AI developer, an AI researcher. AI researcher knows what's happening behind the scenes with respect to the algorithm. So he has a very deep understanding of these algorithms, and he can kind of come up with his own algorithms if there is no off-the-shelf solution available in the market. On the contrary, if you're talking about a AI developer, he doesn't understand what's beneath the hood, what's happening, within the algorithms. He would know how to use some of the TensorFlow libraries, but never misunderstand that an AI developer can actually solve some of the problems. He can solve the problems that are available off the shelf. If there is a library already available, he can kind of use it and he can implement a solution based on that. But if there is a problem which is unique in itself, then it becomes kind of very difficult for him to comprehend with respect to what's happening within the problem itself. So understanding the problem in its entirety is the first step to the solution. I got some message. Anyway, let me carry on. So what I'll do is I'll try to go as slow as I can. What I have to mention here is understanding AI. It takes a lot of time. It takes many years for us to actually comprehend the complexity of AI, to understand it. And the more you understand, it'll humble you even more and make you realize that how much little that you know. Because I have my friends who are doing PhDs in AI, and I sent him a note because I helped him get to a university in Norway. I helped him in his project thesis, and he got selected in both the universities on scholarships. So I asked him, what's happening? Are you getting to understand AI? And then he said, it's a very vast subject. It's a huge subject. I've seen PhDs in AI struggling to solve some of the problems in the industry. So not all problems are the same. If you get into AI and data science, one will realize that every problem is unique. And to work around every problem, one has to understand the basic fundamental concepts behind what's happening with respect to the data. It all boils down to statistics, probability, basic math. We'll get to there. But before that, let me start this session, inshallah, with a very brief demo so that most of you must have seen this. But I thought let me take you through. Like our phones recognize us, when there is face unlock, face recognition technology. So let's look into some of that now. Have a demo that I have created. Let me just run that. So yeah, and what this program does is, let me show you the program. This is that program. If you're able to see my screen, this is that program. It is using OpenCV library, and the algorithm is, a binary patterns algorithm. It's a very simple algorithm, but for a demonstration, I think this should work good. So where am I? Okay. So you see this, we'll be basically training the algorithm, we'll be running this algorithm to create a database of images.
I am a machine and I need data in order to classify and identify. I am an algorithm that detects and identifies faces. Hence, in order to identify you, I need to take your pictures. Taking your pictures, give some expressions as told, please. Look straight. Look a little toward your right, just a little. Look a little toward your left, just a little. Look a little upwards, just a little. Tilt your head a little toward your right, do not turn, just tilt. Tilt your head a little toward your left, do not turn, just tilt. Smile, please. You did great. You have an incredible smile. Keep smiling and have a nice day.
You heard that audio in the background? Hello?
Yeah, everybody is on mute, so yes.
You heard the background machine talking?
Yes.
Yeah, there was a glitch in the program. I don't think it has taken the images because of the lighting discrepancy here. So real-time databases, Syed. No, it hasn't taken. This is very sensitive towards the lighting. For some reason, my laptop has an issue. So this has not captured the images. It's not able to recognize. So how do I do this? It'll be easy for me to basically proceed with this demo to have, anyway, let me use a book to see if this recognizes. One more time. Ignore the background noise. It's Ramadan, so someone is cooking and the birds are, we have some birds at home, so ignore that. My apologies.
I am a machine and I need data in order to classify and identify. I am an algorithm that detects and identifies faces. Hence, in order to identify you, I need to take your pictures. Taking your pictures, give some expressions as told, please. Look straight. Look a little toward your right, just a little. Look a little toward your left, just a little.
I think WebEx is not allowing me my Python program to access and identify these images. I did it in Zoom. It was working. In Python, I mean in WebEx, it's not kind of taking the images. Although I see the camera, but there could be some discrepancy. So nonetheless, I thought of giving that a demo. We'll skip that. Probably we'll keep it sometime for later when we work towards using Zoom. I had given a presentation earlier on Zoom, and that thing worked. Let me go back to another demo in that case. Yeah, that would have been a good demo for you to understand how kind of our phones recognize us. Nonetheless, we'll move on to this demo. Okay, we'll be going through object detection. It's based on deep learning algorithm. It's a cafe model. If you know, there are a couple of models like TensorFlow is one framework. There is Keras that runs on TensorFlow. We have another model called Cafe, which is a convolution neural network model. Now we have a bunch of images here, and I have my model that I can run. Give me a second. Yeah, so here, so let me just take one of this, and you see those images, right? Like we have a bunch of images. We'll have the algorithm recognize these images. So we are running this, model. A model is something that you train. And then you give test data to basically predict what the output is. So to prepare a model, you will have to go through training data, which is the kind of demo I was trying to give earlier, which it was not working for some issues with the camera. So these are the images, and we will put this images into this model to see if the model is able to recognize them. So assume that AI has been trained to recognize objects, animals, and we'll see how best it will kind of recognize, identify what kind of object we are giving it for the algorithm to recognize. So in our case, we'll be giving this image. You see this boat image, boat JPEG. It's here. You see this boat JPEG. We'll give that image for the algorithm, which is based on this cafe model, CNN, and see if it recognizes. You see, it's 99.78%. You see this blue box around the boat. These are called bounding boxes. And this is one way in which the algorithm is basically trained to identify the edges within an image and then recognize that particular image based on a CNN model. So now you know how self-driving cars work, but they're very dynamic. As they are moving, they kind of recognize what objects there are. The earlier demo had covered that a bit, although it's a face recognition, but I could have explained you how self-driven cars kind of work with that kind of model. But they're very, very accurate. It's not like, so the algorithms are pretty decent. So we have this recognized, and then well, bicycle. Let's use this. So bicycle. deep. So paste, it's a bicycle. You see, it's kind of identifying, but the bounding box is gray, so it's not very. So let me take you through some other images, like bicycle, just bicycle. You see this image. Let's do that. You see, it has identified two people. One is person, 99.99%. The other is bicycle, that is 99.99%. So this is based on single shot detection, where given an image, the algorithm can recognize multiple objects within an image. So it's a multi-classifier. It's a classification algorithm that can identify multiple objects within an image. So we have that. Just a second. Let me pick a very recent. Maybe example 5. This example, we have many objects there. Example 5. There you go. See, you have a person, it's 88%, horse 99%, dog 61%, car is 99%, and then you have some people in the background. They are not able to be recognized because the edge detection algorithm has some constraints based on which it works to classify multiple objects within an image. Okay. So let me take you through this sheepdog. Sheepdog, it's a little difficult. It looks like a sheep, but it's a dog. Let's see if it identifies that. We have another image for sheep. We'll run both. Sheepdog. Let's see that. There you go. It's dog, 99%. So this algorithm, the cafe model, this thing is pretty decent. Okay, sheep, only sheep. We have only sheep. There you go, 99.99%. So now you know how a computer can detect an object, and that's how our phones identify our face. It's a face recognition. It can identify us with the same kind of accuracy. It's only that I wasn't able to run the demo. Kind of saddens me. So you saw a bunch of things here, and let me give you one last demo of the limitations of this. We have horses here. Let me show you the limitations of this. Why data really matters a lot. So we have horse 2, which is this. So horse is 100%. Okay, so we get to know that okay, it recognizes images with respect to horses really well. But let's give this image, which is a horse 1, this image that you see, and see if it kind of recognizes that. You see, it's a bird. It's a person. So now the AI is gone for a toss, because AI is not trained on these kind of images with respect to horses. So that's a limitation of AI. So when you're working with AI, one should understand this limitation. It's not that AI is going to do magic. Behind the scene, it's all about math. We have dimensionality here, and it's all pixels for the machine, and the machine is kind of classifying those pixels and differentiating between what pixels are of a different value and what object do they belong to. That's what is happening behind the scenes. So here you see one use case where we had one use case earlier where this model was able to recognize a horse with 100% accuracy. Now it's all jumbled up. We have a person, we have a bird, we have whatnot, but we don't have a horse here. Okay, so let me go back to the demo. So we went through that. So with respect to AI, I'll take you through NLP. But what we understood was we saw some with speech where a machine can talk. So again, behind the scenes, it's AI that is working. And we also saw images, how a machine is able to identify images. And with respect to language, natural language processing, does a machine know or identify how things with respect to language or NLP is related? So let me take you through one use case. How do I? Okay. See, Google is all about strabismus. This is natural language processing. What we see in Google, we give a search query, and then the search algorithm behind it kind of returned many results. This is based primarily on vector space model, wherein all these results are vectors, and it has a relevance algorithm beneath the hood that identifies what is most relevant and brings up these results. But if you are applying deep learning to some of the natural language processing problems that we face in NLP, there are two things. One is speech and the other is written language. Written language is the documents that we write. And in this case, we are talking about written documents. So you see, Google is trying to bring context around strabismus. It bought cross-die. And of course, this is from some source, Apollo Hospitals. So and it's kind of giving things that are related with respect to strabismus. Let me show you one more search, Medboon. This is a pre-alpha search engine that Alhamdulillah I have developed. It's taking a while to connect. I'm not sure if the server is up and running. Medboon cannot be reached. Okay. Okay, we have some issues there. I have to check. Okay, anyway, even this is not working for some reason today. Fine, then we'll go ahead with the presentation. We have two demos that I wasn't able to give. So looking at AI with respect to general terms, with intelligence, what do? We identify, recognize objects, images, we speak, we also read documents, natural documents, we write those documents. Much of what we do, in some sense, a machine is able to do at some level in a constrained environment, though. It doesn't have a general intelligence, which is the current research trend in the industry. But at some level, as I said, constrained, in a constrained environment, a machine can talk, a machine can understand, because there is speech technology. You can talk to Alexa, it understands. Machine can do face recognition, it can see and identify. It can also write, it can read. Google kind of reads, it kind of crawls the web, it is reading the web. And you can have algorithm that can go through a document and write a summary of it. So much of what we do is at some level being done by machines at this point of time, which is the reason why we call AI as AI. It's artificial intelligence, because there is intelligence, not inherent intelligence, but it is intelligence that is basically taught to a machine basis training using ground truth data. So what is artificial intelligence? According to John McCarthy, who is considered to be father of artificial intelligence, he said it's the science and engineering of making intelligent machines, especially intelligent computer programs. So intelligent computer programs, in other words, we call them as models, we call them as algorithms. So those are intelligent programs. Like you saw a model earlier, a cafe model, that's an intelligent computer program. End of the day, it's a bunch of code that is written beneath. So where are we heading to? If a machine can see, if a machine can talk, if a machine can read a document, understand if it can read and write, then you are trying to build an operating system for a robot. Robots are already there, like Asimo, a Honda robot. Robots from Boston Dynamics that can run, jump, do a somersault like gymnasts. They can do all of that. They can balance. There is a huge research being done with respect to gyroscopy, and people do PhDs in that, but that's a very solved problem now. Using gyroscope technology is so advanced now. SpaceX has been able to develop reusable rockets that can launch satellites and then come back and dock themselves. They can park themselves, back without falling, and that is all happening because of gyroscope technology. So the rockets are kind of able to balance themselves and land, basically back. And so what I mean to say is there is a abundance amount of research and progress with respect to gyroscope. Gyroscope is basically balancing something. A gyroscope is used in many places where like planes use gyroscope. Anywhere where balancing is needed, you use gyroscope within a machine. So there is a huge research been progressed with respect to gyroscopy. So developing a robot that can run and walk and do all sorts of things, balance itself when you push it, it's all solved problem. What is not solved is the intelligence behind. I'm talking about general intelligence. It's still not there. So unless it is developed, it's just a matter of time that we'll see these kind of machines walking around, because they'll be experts in identifying, recognizing objects. They'll be very well versed with understanding speech, talking back. You have natural language processing, sentiment analysis, and all those kind of algorithms, right? They'll all be bundled up into this. So that's where we're heading. We're heading towards general AI, artificial general intelligence, AGI. You can Google this thing, AGI, artificial general intelligence. That's the next level of AI that the industry is moving towards. It may be a decade from now that we'll be into AGI from AI. So AGI will be uh, promoting logic, math. Logic is somewhere most of the AI programs lack a bit. With respect to logic, it's very difficult to comprehend. So that's AGI. AGI is trying to kind of address that particular problem. But when they do that, these kind of machines are very obvious, which is the reason why we need AI to be regulated. You saw Google Sundar Pichai speaking about AI regulations. AI has to be regulated. Otherwise, you can use AI for many things, and those many things are dangerous for humanity. It has to be regulated where AI can be used, where AI cannot be used. That's the thing that we are heading to. Now, this is an AI tree. You can take a note of this tree. I had a chance to download from the internet while I was surfing. Um, AI has many branches, like you have machine learning, and you have in machine learning you have deep learning. We'll get to know what deep learning is, and how different it is from neural networks, um, basic neural networks. Of course, deep learning will also have a neural network. It's an advanced neural network, but we'll get to know what deep learning is. Unsupervised machine learning, supervised machine learning, the difference between these two. And in natural language processing, we just spoke about it. Text generation, where a machine can write. Question and answering, where a machine can understand a question, answer back with knowledge base. Context extraction, we are talking about contextual relationship. The demo that I was about to show, for some reason, the Medboon is not working. Anyway, classification problems, machine translation. Google does this. Expert systems. Expert system is where AI actually started with having a dictionary, an inferential dictionary, and then the machine kind of infers based on if-else rules. So that's the basic AI program. And I remember when I was doing my engineering way back in 90s, 96, 97, 97, I think, we had a chapter on expert systems. Primarily AI started with this. Most of the problems were basically with respect to inferential analysis and forecasting were based on expert systems. There were a bunch of algorithms called SVD, but then AI was not known as AI, it was known as pattern analysis. So AI was debatable in those days. They used to call as pattern analysis. Okay. And then we have speech to text. We've seen machines doing this. We have speech technology. It's improved a lot. In 2003, we had one speech engine, which was good, called Nuance. Based on Nuance, I think Siri works based on Nuance. And we had a bunch of other speech engines that were not doing very good, but Nuance was a pioneer in advanced speech engines. But now we have so much of speech technology spread across so many devices. We have image recognition. We saw that a while ago. And we talked about robotics briefly. We are talking about planning. I'm currently doing a project on planning based off a US company where AI kind of plans based on past history. It kind of forecasts going forward the things that are there. That is all that I can say. It's a confidential project, but yeah, it's also used in planning. Okay, AI in its true sense, a combination of vision, speech, natural language. Logic is somewhere, AI is still lagging behind, which is where I was talking about AI general intelligence. So that's all about this. So people usually debate, you know, what is AI? And I've had a chance to come across people um, who really don't understand, unfortunately, um, concepts like you know um, algorithms and statistics, but they kind of debate on what AI is. Why is AI called AI? Why don't you just call it an algorithm instead of calling it AI? Why is it intelligent? Those debates are always there. But doesn't really help anyone. So AI is actually based on statistics. AI builds on statistics. Without statistics, you cannot have AI. So for statistics, you need a lot of data, which is the reason why people say data is gold. Data is the next oil, is what some articles actually talk about these days. So for AI to actually work, data is very important. Data is basic need. Without data, you're going nowhere. And that is the reason why big data and all these kind of technologies have been so popular in these days, because once you have big data, when you have lots and lots of data, you can actually do analysis on the data, bring data intelligence, data science, run data science on it, bring analytics, and then based on the analytics, you can come up with some custom algorithms to bring in business intelligence, business forecasting for some of the problems that you're trying to solve. And okay, what is the difference between AI and machine learning? I unfortunately come across many people who enjoy trying to argue on these two things. And I think some people really enjoy arguing. For them, this topic is a hot topic. They can always go back and spend some time or waste some time. Uh, so uh, see, you have to, as I said, end of the day, be it AI or machine learning, it's all math behind. So it really doesn't matter what's happening, whether you call an algorithm as an AI algorithm, a machine learning algorithm, whatever you call. But end of the day, you have to understand that there is some math that is behind, which is the reason why I've written here. Machine learning, by the way, can be seen as glorified statistics with a combination of probability theory, linear algebra, bit of calculus for optimization. These are building blocks for machine learning. AI is more abstract. It's more where machines to make machines intelligent. It's called AI. And machine learning is more of a specific way of trying to solve a problem. So that's all about it. I would keep it that way. AI is more abstract. Machine learning could be taken as more concrete, whatever. But the debate continues. I'm not really interested in that, but I put a slide here because people usually debate on that. Particularly people who are starting with AI, they love to talk about this for whatever reason. But I would advise not to waste your time on this. Focus on learning some algorithm rather than wasting your time trying to debate on this. I've come across many people who have started AI and they kind of jump into this and start debating and discussing on this thing. So you can always listen and enjoy the debate. So I was talking about these algorithms earlier. Deep learning, unsupervised, and supervised machine learning. So we are on this slide here. So machine learning, supervised learning is where I give a bunch of data to the algorithm. Like I have this MNIST data to recognize digits, and you see this data from here to here. This entire vector, entire data. This you see some numbers here. These are pixel values of an image for the digit 7. So this is the training data. This is what the machine will digest. And if you want to see a neural network based off of this, let me show you what this. Let me show you. You see, input node 784 pixels. It's a 28 by 28 dimensional picture. There are 784. Those are pixel values that you just saw. These are pixel values, 0 with some numbers in between. But those numbers represent digit, 7, a image of 7. So this is the training data for a machine to basically recognize digits. So you work with this training set. Now this is the training set. This is a pixel values for 7, and you give this as a label. A label will help a machine understand, okay, this pixel values that I see, these pixel values belong to this label called 7. So whatever pixel values that I hear will converge to this label 7. And based on statistical data, you have 7 here, you have 7 here, you have many 7s. It'll basically build upon that, and that's how neural networks work. You basically train the network with the labeled data, and you will train that model to identify, okay, this bunch of pixels, they form this particular digits. Like earlier we saw image recognition algorithms where a machine was able to identify a horse, classify multiple objects within an image. That's how this label data is given. So behind, someone has given lots of training data of how a person will look, how a bicycle will look, how a sheep will look, how a dog will look, how a horse will look. So those are label data. So there is a lot of data curation, data preparation. And then when you give this to a machine, there is data pre-processing that is done to normalize the data within, before feeding to the neural network. I know this is very difficult for people who have no background on computer science to digest all of this, but I'm trying to be as simple as I can. If you're not able to understand, it's still okay. But I just wanted to give you the essence at a very high level of how things in AI kind of work, to give a feel of how this kind of works. But for you to actually understand each of this, like natural language processing by itself is a huge field. People who specialize in NLP, they kind of spend their lives in NLP, in only this. And even in NLP, if someone is working in information retrieval, he'll be spending so much of time building algorithms on relevance. Like if someone is working on chatbots, they spend a lot of time working on answering NLP based algorithms. Someone who is working on machine translation, they kind of spend their lifetime. So these by itself is so huge that one can a lifetime is actually pretty small to actually be an expert in any of these fields. So I would say if you're getting into AI, if you really have passion to learn and you want to always learn, which is true with knowledge, I think it's you're good to go with AI. So that's with supervised machine learning. Unsupervised machine learning is somewhere where we don't have this kind of labeled data. We just have data. You just remove this particular column and you just have data. Now it's up to a machine to run this data. If I delete this particular label, I have a bunch of numbers. Now I just give these numbers, these pixel values without mentioning what these values are to a machine. And now a machine has to run this bunch of numbers and cluster them. It has to cluster sevens by itself. Like in label data, I have specifically mentioned 7 number here and here, and there are many of those beneath, like 1. This whole row represents 1. Again, we have another one here, and we have another one here. So what a machine will do here is I have like 0 to 9 numbers to identify. It will cluster based on the pixel values. So if algorithm is really good, it will cluster 10. It will make 10 clusters starting from 0 to 9. And then cluster whatever is common, like 7 pixels. A pixel value of 7 will be close enough. So it'll cluster and then it'll learn on its own. You don't have to train it. And those are the algorithms that are highly required in any problem solving if it is a problem that dynamically changes. So if there is a dynamic system that you're working on, then unsupervised machine learning is a way to go. But if you have a defined problem where you know that these patterns kind of repeat themselves, these data patterns repeat themselves, then you go with supervised machine learning. Reinforced machine learning is primarily used in many places, particularly in self-driven cars, where you allow a machine to make a mistake, an algorithm to make a mistake, and then you say if it's a mistake, it's a mistake. What is the right thing? And then if it's the right thing, then you reward. You basically put more weightage to that. I'm not sure if I'm very clear, but in a nutshell, that's how it kind of works. You reward if it's right, and if it's not right, you basically correct that, and that's how it's kind of it works. It's kind of incrementally keeps learning. It always keeps learning, and that's true with deep learning as well. See, what happens is if you're running a neural network. An analogy to understand deep learning, I will take a neural network example. The training becomes saturated. Like you see here, older learning algorithms. Here you see this saddle point, as we call, this is saturation point. Post this, the more the data you provide to the algorithm, there is no improvement on learning, which means the model has saturated. And if you give more and more learning, more and more data for the algorithm to learn, then it will overgeneralize. That's a problem. So with neural networks, there is a effort involved in empirically testing how much you train the algorithm with the data. And you have to stop exactly where it is needed. And that's a trial and error method where you keep checking the performance, which is why you run epochs. Like in neural networks, this is one code where we are running epochs. Like for this model, I'm running like 5 epochs on the same data. I run this model 5 times. But if I run it more, it may overgeneralize. So I have to keep checking on the performance of a neural network. And then, I basically apply the model, but there is a cost involved in maintaining a neural network. That's the point. With deep learning, we kind of discount that. We kind of get away with that. The more the data you give, the better the learning is. And that's how Google is based on deep learning algorithms. And much of the algorithms going forward are based on deep learning, because the more the data you give, statistically and speaking, it should actually improve. So that's where deep learning has taken a huge, what you call, leap with respect to popularity in AI. So to understand neural network at a very high level, see, there are books written on neural networks. So one can spend their lifetime understanding what a neural network is, why things are happening the way they are happening within a neural network. Here I'll give you a very high level description of what a neural network is. You can think of a die cast. You prepare a die, and then you put anything in that mold in a die cast, you will get the same output. So a neural network is something similar to die cast. Like this particular neural network that is here, it kind of understands, identifies digits. It identifies digits, give an image and it kind of identifies digits. So you can have specific neural networks developed for solving specific problems. But what it actually does is it takes input. It has a bunch of layers where you have weightages defined. And then since you have labeled data, I give this assume as 1. It kind of the label data says it's 1, until it converges to 1. It kind of adjust the weights using gradient descent algorithm. Let me do this. I'm not doing justice to basically explain this in a very presentable manner because I'm jumping to technical jargons. But to make it much easier, I have to probably have a very separate session to only cover neural networks of what's happening within. Let me show you the weightages. If you see these weightages, this is a weightage of one output layer. This output layer of one of the neural networks that I had a chance to build to identify what drug is given to what ailment. So if we give an ailment, like say fever and cough, the neural network will predict what medicine has to be given for these two ailments. And that model was kind of working. And this is the final layer of that particular model. These are the weightages. See, they're all a bunch of numbers, some negative values, but they're all in between -1 to 1. You will understand nothing. It's like a black box, which is why people call it as a black box. But the black box has a lot of things to do. It's a die. It's a die, but it's a complex die. A die can basically give you one output, but here a neural network can give you multiple outputs. So it's a combination of many dies within one network. You can take it that way. I hope I'm a little clear here. If you have a neural network built to identify digits, so there are 10 dies within that particular neural network where a neural network can identify, take an input, and will try to fit what die, what die this kind of fits in. And if it fits in number 1 die, which it has developed based off these weightages that you just saw, then it will give an output as 1. During the question and answer session, get back to me if I have not clarified this die-cast analogy. I'll try to clarify that. So in the process of learning, what the algorithm will do is it'll kind of generalize. You must have heard of this generalization term when you talk about AI. It's more like Generalization is very important. There is a thin line between generalization. If you don't generalize, you will be overfitting the model. You'll be developing an expert system. Whatever is there in the inferential dictionary, the algorithm will basically refer to that. So it's kind of an expert system. If you say, if you overfit the model, you have not learned. The machine has not learned. But if you have overgeneralized, then you will misclassify the algorithm. The AI model will misclassify. If I have overtrained and overgeneralized a digit detection algorithm, then it will misclassify between 7 and 9, because the pixel values of 7 and 9 are kind of close to each other. You may misclassify between 7 and 1. They're close to each other in some sense. You may misclassify between 8 and 0. So it will get confused between what is the right value for 0. It can also misclassify it as 8. So if you overgeneralize, that's a problem. If you undergeneralize, then you will be landing in a problem of overfitting, where the algorithm has not learned. It can only forecast if I give an input which exactly matches these pixels, what it means as overfitting. If it exactly matches these pixels here, 7, 7, then only it will identify it as 7. That is overfitting. But if it has learned a new value of pixel which actually represents 7, then it has kind of generalized. That's what it means. Again, there is a huge session only to understand generalization. In a nutshell, I just touched upon what that actually is. So algorithms and their fancy names. You must have heard of these algorithms. Support vector machines, singular value decomposition, principal component analysis, individual component analysis, LSI, LSA, Bayesian k-means. These are some of the algorithms. These all 6 algorithms that you see based off of advanced machine learning. And particularly, I would recommend if some of you want to get into AI seriously, then go with SVD. This is one algorithm that kind of inspired me to get into advanced machine learning in 2006. It's a very, very, very popularly, hugely used algorithm in the world. SVD is used right from building bridges to electrical circuits, designing them, to in space exploration in many, many, many areas. You name it, there's so many places where SVD is used. And this is a decomposition algorithm based off a mathematical concept called semi-positive definite theorem. You can Google this theorem. It'll take a while for you to understand this. So we are talking about math. It's based on linear algebra. So that's what I started this session with. If you're talking about AI, you're seriously talking about math, and you're talking about advanced mathematics, discrete mathematics, and stuff like that. So I would recommend you learn this algorithm well. It'll take a long time for you to understand this. Some may take 4 months, some may take 6 months. There are videos on SVD, but they only talk about how to use this algorithm. So if you're an AI developer, that is enough for that much is enough, because there are SVD libraries built in Python and R and any of the programming languages that we see. It's just a one line of code you SVD implement. But if you want to really understand how this works, then it takes a long time, because you'll be diving deep into linear algebra. You'll be having to understand eigenvalues, eigenvectors. The eigenvectors are nothing but the principal components. And you have to have a very good understanding on that if you really want to build some algorithms, custom algorithms based off of these algorithms. So you're talking about SVD, principal component analysis, are kind of same. They are sister algorithms. SVM are a very good bunch of algorithms. We can have a session on SVM itself. This is pretty complex, where you will learn to understand how to transform dimensions, how to bend dimensions. transform in the sense I can see when I have my dimensionality defined, I can manipulate those dimensions, like how we factor a math problem. I can start factorization. Matrix factorization. Matrix will represent your dimensions. Then I can factorize those matrices using transformation rules. And that is when I bend the dimensions, I stretch the dimensions, I do so many things to basically classify the data. So I have one example that I thought of covering, but I think we're running short of time. We'll probably spend some time maybe in some session going forward with respect to some of these algorithms. But if you're getting into AI, understanding of these algorithms is very, very important. Bayesian, I've worked on Bayesian, completely focused on Bayesian for more than 1.5 years. And honestly speaking, if you ask me how much I know about Bayesian, I would say I still have to learn a lot. So your IBM Watson, which is a supercomputer that won Jeopardy competition, beating human experts at length, is based on Bayesian. Dr. Saif, if he's there on call, he knows much about this. I hope he's worked on IBM Watson. Is based off a Bayesian model, completely based on Bayesian model. And Bayesian is a monster with respect to data. You have to feed Bayesian model with huge amount of data. And that's the reason why IBM kind of invested close to $5 billion only to get the data to run their IBM Watson on health, domain. Dr. Saif, are you there? You want to talk something on Bayesian and Watson model? If you know something, he's a researcher, he's a PhD. I don't know if Dr. Saif is around.
Yes, he is. He's on mute.
Unmute him. I want him to talk.
Sure. Sure. You keep going. I'll in the meantime, I'll put him up.
Yeah. Because he's an IBM researcher, and I think he has an exposure to IBM Watson. It's a good algorithm. Anyway, it takes a long time to usually. It's based on graph theory. So graph theory is the future of developing code frameworks. I'll get to that. I'll get to that in a while.
Saif, you can unmute yourself. I think I've made you as a panelist.
Dr. Saif, I want you to talk a little bit of Watson. I just was taking them through IBM Watson based off of Bayesian theory, and I was mentioning to them that Bayesian is a monster, and IBM Watson had to buy close to 5 billion worth of medical data to have their health program running on Watson. So if you had a chance to work on Watson, you can throw some light on the importance of Bayesian algorithm. Are you there? Hello? Hello, did I lose you?
Looks like he's probably on another call or something.
Okay, then let's continue. Maybe when it is off, then we'll get. So, do we continue or do we stop here and start with the next session going forward? Because I have like more than half to cover. It may take a long time. And going forward, I'll be covering with respect to IoT, AI, big data, and primarily on IT. Primarily on IT. If there are too many IT folks, I can just jump into this particular slide now, because this will give you a picture of how IT is heading towards with respect to AI. What do you want me to do?
I see somebody saying that another session is better. I get one comment from one of them saying that another session is better. Those who have any other opinions, please share your opinions on the chat window.
because this will take a long time. I am be talking about multi-agent systems. These are the ways of how enterprise solutions will be designed going forward. Right now, we have enterprise solutions, but they lack intelligence. But that doesn't stop there. Multi-agent system is a curriculum that has started in PhD programs as well as in MS programs in Europe and also in US, I think, in some of the universities. So we'll be learning towards how to build enterprise solutions with respect to a learning agent. How do we like this? This is the future of architecture. It's a very high level architecture, but this
So
will
more,
be
so sorry to interrupt. Yeah, most of them I'm seeing are preferring to have another session, except one person requesting if can one use case on IT can be spent,
okay. Let me just quickly brush through this. Probably we can have a detailed session in going forward. Let me go here immediately. I'll just touch upon this. We'll cover the rest of the things later. So this is the programming language that are popular. This slide is outdated. It's 2 years back. My apologies. I have to update this particular slide. If someone can help me send a snapshot of the latest one, I think Python has gone up. C++ has gone up. R has come down. But that is what it is like. AI, IT, how it works, future for software developer, QA tester. Testing AI will be used largely. I had a meeting with one of the MNCs. Tech Mahindra had called me on advice with respect to testing. They want regression testing to be taken care by AI. And Infosys is doing a lot of stuff there, so they want to keep up with the competition, and they are struggling to reduce cost with respect to regression testing, where AI can do the repetitive tasks. So that's the future of testing. So testers, it's very important for you to get into AI, because if you're there, you will be one of the key resources in the company. And if you're an IT guy who has a very good architecture knowledge, who is an enterprise architect, please get into AI, because the future of architecture will be based off of AI. I'll be covering, systems without AI. This is where we are with respect to enterprise architectures. They are static in nature. There is no learning. They are repetitive things that are missed out. Knowledge base is difficult to maintain because there is nothing that is happening with data analytics. It's very obtuse. Systems with AI are dynamic. There is learning. They are adaptive to change. They are intelligent. Now, to build this it's very challenging. And if you have the skill set, companies will be holding your hands. Trust me, they'll be holding your hands to join their organization. And that's where I would encourage you to be. You be out of the crowd. You have to kind of slog for that. You have to really kind of work for that. But that is fun. I mean, that is the kind of discipline we are taught from day one. May Allah also help me with that discipline. I only talk, but I'm also falling short of that. So AI and IoT. AI big data is needed. As I said, statistics are very much important for AI to run. So and big data is basically data from all the adjacent systems within what you call say enterprise. And then AI can run on top of that. So that's where IoT, AI, big data, they all get connected. And machines can be good. I will not get into this slide. A typical architecture of a IT, enterprise solution would be this. You will have AI algorithms in the core. You will have learning. Learning, this is basically, this green thing represents data. So whatever the data that is there in the database, sometime back when we used to work using MySQL, Oracle, all these kind of databases, the database was just there to maintain, retrieve, insert, retrieve, and do nothing. There is no learning that is happening. But then the database will be used for learning. And then you have an application wrapper on top. So this is, I basically created this simple high-level architecture, I would say, because everyone will be able to recognize and implement, because this bullseye, we've been seeing this for a very long time, since our childhood. So remember, bullseye will be AI algorithms, and the next will be learning, and then the third layer will be application. We are building applications without these two. without AI algorithms and learning with respect to enterprise solutions these days, because there is a very scarcity of skill set with respect to that, which is where we are getting into multi-agent systems. Multi-agent systems will help you understand and architect, intelligent enterprise solutions. So this is a very simple agent. This is your MVC, model view controller architecture, where you have a view, input output, you have a model, and then you have your database, model view controller, you have this database, you have some rules, and then you have a user interface. It's a very simple agent. This is the kind of programs that we've been developing and seeing for quite some time, but then the future would be this. So this architecture to this architecture, you can see with DB we have analysis. Here we have database, but here we have analysis. And this will be a bunch of algorithms based off of AI. And with analysis comes learning, and with learning comes knowledge, and with knowledge comes, forecasting, decision making, trying to be intelligent, which will be fed into the logic that we have built in, and that will in turn help the users. Of course, knowledge will be validated by human experts so that AI makes mixed mistakes. But if an algorithm is like 90% accurate, then there is a human effort of 10% involved to basically clean that up. So that'll be more practical to critical systems. And then this is a model agent. I've just rushed through this particular architecture just to give an overview. And we have multi-agent model where we have, this is agent 1, agent 2, agent 3. We can have many agents. Each agent is doing a specific task, but at the same time, these agents communicate with each other. So there is a communication protocol, which is where this control architecture comes in, which coordinates all the agents. And these agents can work together. Like one agent is, it's more like object oriented, I would say. One agent is designed specifically to do one task, and it only does that. Like say, for example, in telemedicine, let's take a telemedicine example. I have a multi-agent system built to identify and using IoT, identify a heartbeat and blood pressure of a patient or of any individual for that matter. Now we have watches that kind of monitor BP. So assume that we have such device and it's kind of feeding data in big data in the cloud. And then that agent does only that. It kind of captures the BP and it reads and it kind of stores in the database. But if the BP value is beyond a certain limit, then it basically gives that to a control architecture. That message is posted into this control architecture, and the control architecture will then pick up another agent that knows what to do with that kind of BP. So that agent is designed to take the BP value, take the patient unique primary key, and then send an alert to his doctor via SMS. And the doctor gets get an SMS that okay, his patient, his BP is actually it's above normal now. So probably, so we are talking about a proactive solution as opposed to a solution which is very static and staggered and slow in nature. So that's how multi-agent system will help you build dynamic systems, dynamic solutions going forward. So you'll have AI as a core, you will have a bunch of algorithms that will be fed into this, and you will have an agent, multi-agent model based off of which you will develop an architecture, and these will be the intelligent features outside, and this will incrementally grow as you progress. And that's with respect to that. And this is some of the pointers with respect to multi-agent system. They're methodical, functional, algorithmic, and reinforcement and deep learning is much involved, particularly reinforcement learning. And there's some snapshot of AI and IT, how they're trending. This is some literature that I got. And only with healthcare market, that's 1.5 billion So these are some of the statistics. So it's huge. We'll get into some of the advanced courses. We'll be focusing on just neural networks, reinforcement learning, deep learning. We'll take specific algorithms and work on that. And this is a snapshot of this complete bunch of algorithm. Let me kind of how do I blow this thing off? See that? These are a bunch of algorithms. If you have time, spend some time understanding these algorithms. But before you get into algorithms, I would recommend you, if you're really planning to get into AI seriously, I would say there's a lot of learning. If you really enjoy learning, you should not stop. Have fundamental understanding of math, statistics, probability theory, linear algebra, and I think that is enough for you to start with, and then start looking into these algorithms. Because without this, I mean, much of you have actually gone through this in your 10th standard and your +2. And also in your engineering. In your engineering, you cover with time series math, Fourier transform, Fourier and Laplace transforms. But I think we're not getting there with that kind of math. It's more towards basic math of what we have done in 10th and 12th. So have that mathematical background revised, and then you get into these algorithms. Because without having refreshed the math that you've already learned, if you get into these algorithms, then it's a very different language. You'll be talking about learning about transformations, and you'll be talking about span. You'll be talking about so many words which are very alien to actually hear. We are not used to that. The vocabulary is very different. And for you to comprehend one sentence will take a long time, and you will really not enjoy. So have a mathematical background refreshed, and then you start picking one algorithm at a time and start trying to understand. And without understanding any of these, don't jump to the next. That's one way of learning. So dimensionality reduction is hugely used in machine learning. So don't miss on this, which is why I said focus on singular value decomposition technique. That is a famous dimensionality reduction algorithm. So that's it from my side for now. I think we've spent some time, and I'm already, I think, since it's Ramadan and the last fast are there, my uh, mouth is already dry. So I think we'll cover, if we've spent some time, we'll probably take cover whatever is left out, and some of the demos didn't work. We'll probably take that in the next session whenever I get time, inshallah. Uh, so I apologize, I couldn't prepare much because I was busy throughout the week. I just spent some time, half an hour before this presentation, to do whatever I can. I have taken this earlier too, but then I think I try to do the best I can. But inshallah, we'll keep up with the demos, inshallah, in the next session. And then we'll try to cover whatever was not covered in this session, inshallah. So any questions you have? Hello. Any questions? Let me see the chat box.
Yeah, sorry, I was speaking on the mute button. Yeah, I have a question from Fayaz Basha, who basically is looking for some guidance on how to enhance or look into. I think you kind of answered it, but basically he wants to upgrade himself on ML and AI, and would like to know some resources that he can get onto.
As I said, see, what happens is usually you jump into Kaggle, and you jump into Udemy, and you jump into many of such places, which is good. But as I said, you will have to have a very good understanding of the math that we actually learned in our 10th and our 12th. If you really scored good numbers, you're fortunate. You just have to revise that same math. And the reason I say is AI is all about math. You will have to have fundamental concepts on statistics. Statistics will help you with regression, regression techniques, because regression is based off of statistical analysis. And have your statistics revised, and then probability theory, because when you forecast, when you predict, your forecasting is based on certain percentages. Like for object detection, when I basically gave the demo, you saw machine was putting some percentage there, 99%, 98%. That's based on probability theory. So have your probability theory refreshed. Bayesian is based off graph theory, and it's nothing but probability theory. It's all based on probability. Your statistics, your probability, your linear algebra. I talk about linear algebra because you're talking about multidimensionality. If you have two objects to be detected within an image, you're talking about multidimensional concepts. And to basically have anything converted to multidimensionality, you would need matrices for that, because linear algebra, it's all about vectors and multidimensionality. A vector is a representation of multi-dimensions. You can have millions of dimensions, and a vector can to represent a vector. That's where search engines are based on. It's based on vector space model. So Google kind of scans through millions of dimensions and brings you that closest vector based on cosine similarities. These may not make sense to you now, but these are very important if you want to get into AI. Have your concepts on math refreshed. I insist on this before getting into any algorithm on YouTube. If you're looking at YouTube, look at videos that will help you understand the math that you've already learned. And once you have a very content, and when you're content with the understanding of math, and then you move on to these algorithms. I have a comment here in a chat box that I'm a network tester. What I need to get into AI tester, network tester. You're talking about network architecture that is there in the companies. Talking about ethical hacking, or is it got to do with some performance testing? That I didn't get it. But nonetheless, if you're into network, there is a huge research done on network security. If you're a security analyst, and huge research actually done in Israel on network security, and even in US, where they build some network intrusion detection algorithms. I had a chance to work on one algorithm for network intrusion detection on network security. There's huge AI. It's all based on patterns. So there is a lot of scope. If there is some tester in IT that wants to get into AI, as I said, there are companies, be it Infosys, Tech Mahindra, they're all struggling with. So please pay focus on AI. If you're getting into AI, and if you're able to prove that you can build a script, AI script that can do regression testing, trust me, the companies will hold your hands to join them. Some books, online courses. If you want to get into books for AI, have your math clarified, as I said, refreshed, and then you can look into this book called Rashid, Make Your Own Neural Network by Rashid. And you can also have one book. Let me write this. I forgot his other name, Rashid, for neural network. And refer this book. If you're getting in neural networks, refer this book for Rashid, because he's covered some Python code as well, along with basic explanation of how a neural network will work. If I have to take a session, I will probably refer his book. Much of the content that I will put in a presentation will be based off of his book, because it's very, very clean and neat. Refer his book, Rashid. And there is one more book, this is for advanced people who have some understanding on AI already. This is written by Peter Norvig. He's the director for Google Research. and he's written a phenomenal book for what is the name of the book? I forget the name of the book. Uh, just type Peter Norvig AI. You'll probably get his book. I've kind of put this on chat. Peter Norvig is the director of Google Research. Refer videos of, if you're getting into NLP, refer videos of Professor Manning. Professor Manning on YouTube, and for NLP, and for ML in general, refer videos of Andrew NG. Andrew NG, Andrew Nag, refer his videos. So I think this should give you a bit decent start. But trust me, to get into AI, even if you're joining any institute, like some of there are courses on AI, even they take like 2 years to rush through, and they actually rush through. It takes minimum of 2 years, and that is rushing through. But for you to actually comprehend AI in a very decent sense, it's going to take a long time. And that's the reason I said if you enjoy learning, you would really enjoy AI. Because that's very fascinating for someone who enjoys learning. So I have some for working individual. What should be the approach? How long does it take? Invest average 14 hours a week. Yeah, as I said, if you are investing on an average of like say 2 hours per day, even 1 hour per day, it'll take a long time for you to comprehend. It should take about 1 or 2 years to decently get started with it. But if you have very good understanding on the fundamental math, you'll be much quicker. Again, some people are smarter. They take much less time. But in general, I think in about 1 year, 2 years time, you should be decent with AI. Focus also on the math, as well as start learning Python and R, because these programming languages actually help a lot with respect to implementing these models quickly. So any other questions? I have some questions if I have missed.
There's a question from Harish who asks, how much data does it take for a system to get to a spot where it can learn and start making decisions? How much data is minimum needed when it comes to learning?
Yeah, see, the data actually depends on what you're trying to accomplish. It depends on your problem. So problem formulation is very important. And then you basically run with whatever data you have, and you will be able to actually identify and recognize if the machine has learned or if it's not learned based on specificity and sensitivity analysis. You have to do this. And if the data is less, you'll get to know that the data is you're short of data. Like if you're working on Bayesian model, for example, I worked on it, and after developing the model, we realized that the algorithm was the model was not able to identify some of the things, and then we realized that the amount of training that is given is very, very less. So it needs more data. So it all depends on the kind of problem you're trying to solve. If the problem demands a lot of data, then you will have to kind of feed with that kind of data. So that's where it is. It's very, very subjective to the kind of problem you're trying to solve. So there is no specific answer to that. It all depends on the problem.
I think with the interest of the time, probably we can take some of the other questions in the next session. With that, I would like to, I think, thank you, Syed Yasin Sahab, for a wonderful session here. I think, I know it's pretty deep, and I'm sure the people who are participating would have enjoyed it. With that, probably we'll close the session now, and thank you once again for all the participants who have joined on this day, and we will notify you on the next session when we are conducting the next session. And so there's a kind of acknowledgement that that it was a superb session to you, Syed Yasin sir. So with that, thank you very much for joining it. See you next time.
Jazakallah, Jazakallah khair. Please make dua for me as well, prayers for me as well. Even I'm a student, I have a lot to learn. What I know is very little. I've learned that knowledge really humbles you. What I've realized is there is so much that I don't know. So it's always a learning thing. So it is a learning thing for me, even in this session. The more I give, I think the more it helps me learn back every time I take a session or I conduct a session or I listen to some videos on AI. There is definitely there, there that I learn every time. So even I'm a student just like you. So Alhamdulillah, Jazakallah for your time, and let's get back. Let's look into any of the future sessions that we can do going forward, inshallah.
Yeah, I will also be sharing the recording that I have with all the participants. So please, whoever has registered here, I'll have their email IDs, and I'll send a recording link for the to your email ID. Thank you very much.
Jazakallah. Assalamu alaikum.
Walaikum salam.